All right, so let's play with some logarithms. So here are the rules with log base 10, and here's the rule with log base e, because you know ln log base e is the same thing as saying ln of x. We are going to use ln of x mostly, so I want you to be very familiar and comfortable with these, but I want you to know they work with log as well. All right, so let's combine these using the rules. So anytime there's a number in front, that's going to go up in the exponent. So let's do that first. So ln of 3x minus... So I'm just going to do two things at a time. So these two join together. Since they're addition between them, it turns into multiplication on the inside of the argument. And then this subtracted, so I'm just going to join them all together. So I'll get 3x to the 7th over sine of x. So all of that is inside the ln. All right, I'm going to do that again. So ln of x to the 4th. So, oops, not minus. I meant to write minus. So I'm going to move that 1/3 to the exponent, and just so that we're all comfortable, you know that that is the same thing as saying the cube root. And then this is going to be x minus 1 squared. All right, so this is here because these are both subtracted. They're both going to be in the denominator, and all of that is the argument. All right, so let's work on expanding. You're just going to need to be comfortable with both of these. So let's pull this 1/3. You know this is the same thing as saying this. So this 1/3 would come down in the front. And then you'll have an idea of why you will need to separate this, but I'm just going to separate it for each of the three terms. So since they're multiplied, they turn into addition. And then if I wanted to, again, you'll have an idea of why you're doing this as you're moving through problems. You can pull that exponent 2 down in the front. There you go. All right, let's do this. I'm just going to worry about pulling these numbers in the exponent. I'm just going to carry this along. So I'll have plus ln of x squared cubed, give me x to the 6th. This is minus, and this will be the quantity 3x squared. All right, since this was positive, that's x to the 6th in the numerator. This is subtracted, so this will be in the denominator. This will be in the denominator, and if I wanted to kind of simplify it, I get x to the 6th over 9x cubed, right? 9x cubed, and so simplifying x cubed over 9. All right, one more here. So this 2 in the front, if I'm going to break it up around the subtraction, would be ln of x squared y minus ln of x minus y. So this 2 stays out in front, so this multiplication on the inside breaks up into addition. Big deal here, this does not break up. This ln of x minus y does not go any further. It stays together. And again, you would have motivation, but I'm just going to do one more step there and pull this exponent 2 down in the front. So these problems are just exercising some properties. All right, so let's talk about these inverses. So when does an inverse exist? If it's 1-to-1, so like a graph like y equal x cubed is 1-to-1 because it passes the horizontal line test, whereas a graph of y equal x squared is not 1-to-1 because it does not pass only one point through the horizontal line test. Remember, vertical line test is to be a function, right? Horizontal line test is to have an inverse. Okay, so there is a property that there are reflections across the line y equal x. So if I was to graph the y equal ln of x, and then y equal e to the x, they really are mirror images across this line. So if I folded the paper, they would be mirror images across that line. So this point is 0, 1. And then this point here is 1, 0. So x's and y's are switched. So algebraically, so that's illustrating this. Algebraically, when I take the functions of each other, I get x. So using x cubed and cube root cubed is x, and if I take the cube and cube rooted, it's x. Same thing for ln of x. So if I have e and ln of e to the x is x, and that works for all reals. So this is a true fact I want you to know. And then e to the ln of x is x, but remember this x inside here has to be bigger than 0. But e and ln cancel each other out, just like the cube root and the cube cancel each other out. So I just wrote it down here. Log base e of x is ln of x. ln of 1 is 0. So that point right there, ln of 1 is 0, is right there, right? ln of e is 1. So x equal e is right here. That gives me the y value of 1. And then ln, so I just wrote these two things again. So these are just quick reference things you should know. All right, so I want you to be able to use the log properties to see what we've got here. So this can be rewritten as e to the 1/2. You know that 1/2 can be brought down in front. And ln of e you know is 1, so that's 1/2. So that's what I mean without the calculator. Just use your log properties. So same thing here. Whoops, same thing here. That 2 comes down. ln of e is 1, so I just get 2. Here, e and ln cancel, and I get 5. I'd like to cancel this e and ln like I just did here, but this 3 needs to be moved first. So it's ln of 2 cubed. Put that 2 up, or I'm sorry, put that 3 up in the exponent of the 2. Now the e and the ln will cancel, and so I get 2 cubed, or 8. Same thing here. I need to move that -2 before I can cancel the e and the ln. So if I move that -2, then the e and the ln cancel, so I get 3 to the -2, which is the same thing as saying 1/9.